Hey Math 2 kids, in this video we're going to be reviewing what we talked about in our lesson when factoring, specifically if a equals 1. Okay, so let's review what we talked about at the very beginning of the lesson. We talked about distribution. Specifically, we talked about how your quadratics, so ax squared plus bx plus c, is usually a result of two binomials. So two polynomials with two terms. Okay, and when we distribute these together, meaning that we multiply these together, what we're doing is we're taking this first term, x, and multiplying it to both pieces there. So that would end up being x times x plus 5. And we take the second term here, in this case 4, and multiply it to both terms in that second binomial. Okay, so ultimately that's going to end up, if we multiply these together properly, we get x squared, so x times x, plus 5x plus 4x plus 20, just as we distribute these in. And then to get our final quadratic, we're going to take x squared, and we're going to combine these like terms here to get us 9x plus 20. Okay, this process here is going to be really important for us because what factoring is, in a sense, is going in reverse. Okay, we take a quadratic that we are given and we try and find the two binomials that are the factors of it, the two binomials that we multiply together to get that quadratic. Okay, and there are some steps, really important ones. First step here is to factor out any greatest common factors. So that would be if we had something like 2x squared plus 4x minus 8, we could take out a 2 from both of those. Okay, and we're not going to worry about factoring that one, but I just wanted to give you a representation of if there is something like this where we can take a number or a variable out of all of the terms in the quadratic, that's going to be our first step. The least amount of extra numbers in there that we can deal with, the better. Okay, step number 2, and this is the key and core part of factoring. We need to find two numbers, and these numbers need to both multiply to the product of a times c, and it also needs to add to the b value of the quadratic. Okay, and then 3, we complete the factoring process, and there's a couple of different ways that we can do that. We can do that either with grouping or by what's called the X method. Okay, and in my experience, the X method is considered a shortcut. So we're going to go over factoring by grouping first to help us kind of get a visual of what is actually going on in the factoring process. And then I will show you the X method. And once we finish looking through both of those, you get to decide which one you like better. Okay, so we're going to start with factoring by grouping. And what factoring by grouping is basically just this process of distributing and multiplying these two binomials together to end up with this, and literally just step by step backwards undoing that. Okay, so first and foremost, we need to figure out a times c. We need to multiply, we need to find two numbers that multiply to a times c. In this case, our a is 1, our c is 10, so that means that we need to find two numbers that multiply to 10, and they need to add to our b value of 7. Now we may be able to look at this pretty quickly, and see that factors of 10 here, two numbers that multiply to 10, 5 and 2, both of these would also add together to get 7. Okay, so now that we have those two numbers, in factoring by grouping, what we need to do is split this middle term up into two parts, specifically using those two numbers that we found. Okay, because that, like we had up here, we need to have 4 terms here because these first two are made up of distributing the first term of the first binomial into the second binomial, and then this right here is a result of distributing the second term of the first binomial into the entire second binomial. Okay, and we need to make sure that we have those split up so that we can get those evenly. So we're going to take these numbers here that we just found, and we're going to say t squared plus 5t plus 2t, because 5t plus 2t is equivalent to 7t. So it's not changing the value of our function here, it's just changing the way that it looks. Once we are at this point, we are going to split these into groups, just like I kind of did up here. And what we're going to do is we're going to factor out the greatest common factor of these individual binomials that we have created here. Okay, so here, I'm going to color code these a little bit differently so that we can keep track of these a little bit easier. Okay, so the first one is going to be in blue, the second one's going to be in green, but I digress. So we're going to take out the greatest common factor here, which is t. And that leaves us, when we divide t out of both of these terms, we're left with t plus 5. Okay, and then from 2t and 10, we can take out a positive 2, and that's going to leave us with t plus 5. Okay, if we look back up here at this first example, we saw that once we got to this point, we saw that what these things were being distributed into, these binomials here, were exactly the same. Okay, so if we did this process right, we should have the exact same terms in these binomials, which means that we have our first factored binomial. Okay, so if we see from this example up here, whatever is left on the outside here is actually those two terms that make up the original binomial. So we take whatever is left over here, in this case, t plus 2, and that becomes the first factored binomial. And this right here, since we didn't have to factor out anything in the beginning, this right here is our factored form of this quadratic. Okay, that was factoring by grouping. So now that we've kind of seen exactly what it is we're doing, step by step reversing this process, let's take a look at the X method. Now the X method, I'll draw a little diagram over here just to introduce us to it. So this is a little bit more just a way to organize our thoughts than it is to actually solve for anything, but we're using the same general process we did over here by factoring by grouping. We're going to find the product of a times c and the value of b. We're going to find two numbers, so the first factor and the second factor, that satisfy these rules, that multiply to our product of a times c and add to our value of b. Okay, so our a times c value here on the top of our x is going to be negative 18, because we have negative 18 and 1 here. Okay, and then our b value, as we can see, is negative 7. Okay, so we're going to go through and we're going to figure out what are some factors of negative 18. Okay, we have, because this is negative, then that means that one of our factors has to be negative as well. So if we were to say negative 9 and positive 2, these multiply together to get us negative 18. And we see that if we take negative 9 plus a positive 2, that gets us a negative 7. Okay, so those two factors come over here on each side of the x. Okay, the last step that we do here is kind of superfluous when a equals 1, but we'll find that when a is greater than 1, this does become an important part. So we're going to divide these two factors here by our a value. Okay, and the reason it's kind of unnecessary when a equals 1 is because whenever we divide anything by 1, it's not going to change. It's just going to stay the same. But what this tells us here, once we've divided by a and simplified, whatever the solution is here, we're going to take whatever the variable was, in this case it's m, and we're going to say negative 9, that's the same thing as minus 9. Positive 2, that's the same thing as plus 2. And then this right here is now our two factored binomials. Okay, that's the simplest way of doing it. If we were to take a hypothetical, let's say we have b, let's say 2b squared plus 18b plus 40. Okay, our step 1 up here is to factor out any greatest common factors that we have out of all of these terms. We can see here that we can take a 2 out of all of these, and that leaves us with b squared plus 9b plus 20. And this looks pretty familiar to us because it's about the same process that we did up here, just with b instead of x. So ultimately, this is going to end up being 2 times b plus 4, b plus 5. Because if we were to factor this specific quadratic here, it would give us these two factored binomials. We just need to make sure that the 2 that we took out gets included in there in the final solution. Okay? But when we are dealing with quadratics, when a equals 1, these are the ways that we factor them.